All right, let's dive into a problem that looks, well, it looks downright impossible. But I promise you, stick with me, and by the end of this, you're going to see it in a completely new way.
But hang on a second. I gotta warn you, you are probably about to get this wrong. Seriously, most people do. Your first thought, your second, even your third, they're probably all going to lead you straight down the wrong path.
So, here's the problem. We're told that x² minus x plus 1 equals 0. Okay, looks pretty standard, right? But then they ask us for x to the power of 2024 minus x to the power of 2023. I mean, just look at those numbers. 2024, you'd think you need a supercomputer just to get started on this thing.
It just looks impossible, doesn't it? I bet your brain is already screaming, use the quadratic formula. Or maybe you're thinking about just trying to brute force it somehow. But nope, that is not the way to go here.
That way is completely wrong. See, the beauty of this whole thing isn't about some crazy, complicated calculation. It's all about an elegant, simple transformation. So, let's break it down together.
Okay, let's get into our first transformation. This right here, this is the key that unlocks the whole puzzle, and it all starts with that equation they gave us at the very beginning.
What's up? Just watch this. We can play around with that equation we were given. We start with x² minus x plus 1 equals 0. Now let's just rearrange it a little bit. That gives us x² equals x minus 1. Simple enough, right? Now here's the fun part. Let's multiply everything by x. That gives us x³ equals x² minus x. And now for the magic trick. We're going to substitute that value of x² we just found right back into this equation. So x³ now becomes x minus 1 minus x.
And what happens when you've got x minus 1 and then you subtract x? The x's just cancel each other out. And what are you left with? Well, boom. That's it. Just -1. All that crazy-looking algebra, the big exponents, it all boils down to this one super simple but incredibly powerful number. Okay, so this is the crucial point. We just proved that x³ equals -1. This little fact is the foundation for everything that's about to happen. You can almost forget the original equation for a second. This is our new secret weapon. But hold on, we're not done yet. Now we get to the really cool part, the hidden pattern. This is the real trick. This is the bit that almost everyone misses, and it's what makes those giant exponents just melt away. So we take our new key, right? x³ equals -1. What do you think happens if we just square both sides? Well, on the left, x³ squared becomes x to the power of 6. And on the right, -1 squared just becomes +1.
And this right here, this is a beautiful thing in math called a cyclical pattern. Whenever you find a power of x that equals 1, it means the whole sequence of powers is going to start repeating. In this case, every 6 steps. So x to the 7th power, it's the same as just x. X to the 8th is the same as x². And that pattern goes on forever.
That is the secret. Everything just repeats. All of a sudden, those huge exponents, 2024 and 2023, they're not scary anymore, are they? They're just numbers stuck in a simple repeating loop of 6. So what does this mean for us? It means we don't have to calculate anything. We just have to reduce. We don't care about the massive number. We only care about where it lands in that little cycle of 6. Okay, it's time. Let's put all these pieces together and get our final answer. We've got our keys, we've found the secret pattern. Now let's unlock this thing for good. Just look at this. On one side, you've got the scary-looking original problem. On the other, our simple reduction. So how think we do it? Well, you take 2024, you divide it by 6, and you see what the remainder is. It's 2. So x to the 2024 is really just the same as x². And for 2023, divide by 6, the remainder is 1. So x to the 2023 is just x.
And just like that, our so-called impossible problem completely transforms. It's not x to the 2024 minus x to the 2023 anymore. It's just x² minus x. I mean, it's honestly kind of hard to believe how simple that becomes, right?
Now for the final step. Does x² minus x ring a bell? It absolutely should. Let's go all the way back to the beginning. Remember when we rearranged that first equation? We found that x² is the same thing as x minus 1. So let's just pop that back in. That gives us x minus 1 minus x. And what happens? The x's cancel out. Again. And we're left with our final answer. All that work,
All that digging for patterns, and it leads us right back to good old -1. Isn't that just beautiful?
And hey, if you didn't see that coming, don't worry. You are definitely not alone. This whole problem is designed to be a bit of a trick, you know? It's made to look intimidating, to make you focus on the giant numbers, when the real secret is that hidden, elegant pattern.
So that kind of leaves us with one last question to chew on, doesn't it? How many other impossible problems out there in math, or hey, even in life, are actually this simple, if you just find the right key to unlock them? Something to think about. Thanks so much for joining me on this one.